Students, I welcome you in today's session of physics. As you all know, we were discussing a topic electricity, which is your chapter number 8, and in this chapter we had covered out in our previous three lectures most of the topics. So today we are going to discuss the detection of charge with electroscope. Here you can see this is the topic we are now taking now today. So we will now describe how the charge of an object can be detected by using an electroscope. In order to detect the electric charge on an object, we touch the metal top of electroscope with that object, fine, and observe the aluminum leaves. So if on touching the metal of a metal top of electroscope with a given object, the aluminum leaves of the electroscope diverge, or you can say diverge means open. Then the given object has electric charge on it, or the given object is electrically charged. Fine. Same thing, if you touch the metal top of electroscope with the given object, the aluminum leaves of the electroscope do not diverge or do not open. Fine. Now you can see here, then the given object has no electric charge on it if the leaves of the gold leaf electroscope are not diverges. Earthing of a charged electrode. How will you earth the charged electroscope? So when an electroscope is charged, its aluminum leaves are diverged. If we touch the metal top of the charged electroscope with our finger, it gets discharged and its aluminum leaves collapse or fold up. So actually, when we touch the metal top of the charged electroscope with our finger, then the electric charge present on the charged electroscopes flow to the earth through our hands and the body. The electroscope loses all electric charge, becomes uncharged, and hence its diverged aluminum leaves collapse or fold up. The process in which the metal top of the charged electroscope is touched with the finger and its charge flow into the earth through our hands and body is called earthing. So in general, we can say that the process of transferring an electric charge from the charged object to the earth is called earthing. This line is important, please remember it. So earthing can also be done by connecting the metal top of the charged electroscope to the earth directly. Fine. By means of a metal wire, which is called as earth wire. In that case, the electric charge of electroscope will flow to the earth through the metal wire. The electric current in the wiring of the houses and other buildings is due to the now of electric charges called electron through them. Fine. So the earthing is provided in the wiring of houses and other buildings to protect us from electric shocks, which may occur due to the leakage of electric current from our body. Metal wires like earth wire used for this purpose. Now you can see here it is written that electric discharge, production of sparks. So air is a non-conductor of electricity, so normally air does not conduct electric charges or electric current. If however the amount of electric charges on two oppositely charged surface is very large, then what happens, the air between them conducts electricity and in the form of spark. So the passage of electric current in air due to the movement of electric charge is called electric discharge. During electric discharge, the positive and the negative electric charges cancel out each other and the electric spark and a crackling sound are produced. Fine. So in nature, electric discharge within a cloud during thunderstorm produces huge electricity sparks known as lightning along with a loud sound, clear, called thunderstorm. Fine. An electric discharge between a thunderstorm and the earth also produces lightning followed by thunder. We will now explain the process of lightning. So here we are going to discuss what is lightning. So during rainy season, many times we see a flash of light in the clouds in the sky is followed by a loud sound called thunder or gurgle. The bright flash of the light which we see in the clouds is called lightning. Lightning is an electric discharge in the atmosphere between two oppositely charged clouds. Clear? So the electric nature of lightning was established by a scientist named Benjamin Franklin. We will now describe how a storm could get electrically charged and then produces lightning. Clear? So here you can see a cloud is a visible mass of condensed water. This is the whole process how the light of conducting is created. Vapors floating in the atmosphere high above the ground. A heavy dark rain cloud is called a storm cloud. When the storm cloud develops in the sky, the storm winds move upward through the cloud and make the water drop present in the cloud to rub against one another. The rubbing together of water drops produces extremely large charges in the cloud due to friction. So the small water drops acquire positively charged and being the lighter move on the upper part of the cloud with rising winds. On the other hand, the larger water drops acquire a negative charge and being heavier come down in the lower part of the cloud. In this way, the top of the cloud becomes positively charged whereas the bottom of the cloud becomes negatively charged. Clear? Here you can see in this figure 8.4 how the charge are created or lightning is created in the clouds. Fine. So when the positive charge and negative charge of cloud meets, they produces an intense spark of electricity. Fine. So between the clouds in the sky, we see this electric spark as a flash of lightning in the sky. The electric sparks of lightning near the nearby air in the sky to a very high temperature. Due to this heat, the air in the sky expands rapidly and produces a loud sound which we call thunder. So this is the reason that we hear a sound or thunder in the sky. So lightning always occur within a cloud in the sky is called sheet lightning. This is important line. What is sheet lightning? With the lightning which occur within a cloud in the sky. Sometime, however, lightning also occur between a cloud and the earth. Then it is called as fork lightning. So please remember this difference. What is sheet lightning and fork lightning? So here you can see that storm clouds carry electric charges. Now if a storm cloud having negatively charged at its bottom passes over a tall building, it induces positive charge on the roof of the building. So when the electric charges on the bottom of the cloud extremely large, then these tremendous electric charge present on the bottom of the charged cloud suddenly flow to the roof of the building and we see a flash originating coming towards the building. We say that lightning coming toward the building, that the lightning has struck the building, thus the lightning strike the earth or its tall structure. Fine. The lightning strike the earth or its tall structure when electric charge flow between the clouds and the earth through the tall building, a tree or any other object. I hope it is clear. Now we will discuss about here you can see what is lightning conductors. So lightning conductor is a device used to protect a building from the effect of lightning. Fine. The tall building are protected using the lightning conductors. You can see here there is a figure given in your book 8.51. Here it is a lightning conductor given here. Fine. So these are the total working. I am not going into the deep section. You just read it properly from your book. This is the total working of a lightning conductor. I just told you what is the working of lightning conductor. So in this below given figure you can see that lightning conductor. Fine. So now we will move to measure to protect ourselves from lightning. So we can take the following measures here. We can take the following measures to protect ourselves from lightning during a thunderstorm. The first one is no one open space is safe during lightning and thunderstorm. A house or any other building is safe place during lightning. So if we are in an open space, we should rush to a safer place. Clear? This thing we should keep in mind. The second one, open vehicle like motorbikes and construction of machinery like earth move etc. are not safe during lightning. Fine. And thunderstorm. So we should leave such open places or vehicles and take some shelter inside a house. If however we are traveling by a covered vehicle like a car or a bus, when the thunderstorm and lightning occur, then we are safe inside the car or bus with window and doors of the vehicle closed. Clear? Now come to the third one. If a person is in open space when thunderstorm and lightning begin and there is no suitable shelter available nearby, then the following precautions should be taken for protection from lightning. The first one is when in open space a person should never stand under a tree or take shelter during a thunderstorm because there is danger of lightning strike the tree and burning it up. Fine. This lightning can also pass through the body and kill us. So if however a person is in forest, he should take shelter under a short tree because a short tree is less likely to be hit by lightning. Now come to the B1. When in open space, a person should not lie on the ground during the thunderstorm and lightning. A person should squat low on the ground during lightning. So the person should place his hands on his knees and his head between the hands As I will show you in the I will show you in figure, the position will make the person the shortest object around which is unlikely to be hit by lightning. Here you can see the person puts hands in its knees. Fine. So you can sit in this position like if there is a lightning in cloud. The person should stay away from the electric poles as well, telephone poles and other metal objects during lightning. The fourth one is we should avoid raising an umbrella over the head during lightning. This is because lightning may strike the top ends of the metal rods of umbrella and harm us. The fifth one is the TV antenna and the dish antenna fixed on the tall building are especially prone to lightning strike. We should therefore switch off our TV sets during frequent lightning, otherwise the TV sets may get burned. Come to the sixth one. Lightning can strike metal pieces such as water pipes fixed in buildings. So during a thunderstorm, when lightning is taking place, we should avoid touching the metal pipes fixed in a house or building. Fine. I hope clear now. Now we will move to what is battery. There is a difference between battery and a cell. The combination of cells form a battery. The electric cells is a common source of electric current to run a number of devices in our everyday life. For example, electric cells are used in torches, radios, TV remotes, cassette players, etc. Fine. So many devices do not work properly with just one cell because they require higher voltage, more than 1.5 volt. So for their working, the higher voltage can be obtained by combining a number of cells in series. So when the positive terminal of one cell join with the negative terminal of the other cell, then the cells are said to be joined in series. A group of cells joined in series is called a battery. We can now say that many devices need a battery or cell for their working. Fine. As I told you, the combination of cells form a battery. If you combine more than cells, then this formation of battery takes place. A battery of 2 cells given 1.5 into 2 means 3 volts of a battery of 3 cells. Clear? So here you can see that you can form the combination of battery with the help of different cells. Now we will talk about what are the dangers of electricity. Fine. So you have seen that electricity is very useful in day-to-day life. However, it must be used very carefully. Safe use of electricity is must, otherwise it can be fatal. It is because human body is a good conductor of electricity and gets shocked when current passes through it. The electric shock is dangerous and can result in loss of life too. A person who gets an electric shock finds it very difficult to breathe and the lungs constrict. It also affects the heartbeat of a person and constricts blood vessels. There are various safety measures we should keep in mind a person to safeguard himself against shock. What are the safety measures? The first you can see here, these are the safety measures given here. Always use good quality electric wires, switch and sockets at homes and offices. The second one, use fuse or MCBs in all electric circuits. The third one, make sure that no part of our body ever comes in direct contact with an electric wire. Fine. And the fourth one is never touch switch and socket with wet hands. The fifth one, use 3-pin plug. They have an earth wire connection to save human bodies from the electric shock. The sixth one, plug must be properly inserted in their sockets to avoid sparking. And the seventh one, ask electrician to repair fault in main electric line. Fine students, so this is the end of your chapter and this is the end of your lecture number 4 also. Now till at the end I will tell you, here you can see that a figure given here. And scientist Charles Augustin de Coulomb. You know very well the electric charge is measured in coulomb. So by the name of the scientist, we are using the unit coulomb. So in 1736 to 1806 was a well-known French physicist. He was best known for his work in static electricity, developing Coulomb's law. In upcoming classes, in the higher classes, you will learn about the Coulomb's law. So the definition of electrostatic force of attraction and repulsion. So the SI unit of charge named after him as an honor for his contribution to these fields. Now there are some keywords you please remember by yourself. What are the keywords? The keywords are used in this chapter. Okay students, so from this I am ending this lecture and this is the end of your chapter. Do study. Thank you class. Thank you very much.